Alright, now I will show you how you can install the extension for the server level components that we will be using as a part of this unit. And this extension will allow us to use the timestamp plugin. The custom server code that you need to use for any game, in our case, all of the examples that we have been working and we will be working later on in this class, exist on an extension. For your Electro server to use an extension, you need to copy or place that specific extension in a specific location. That location in your Electro server file setup is in the extension folder. So if you go on your the location that you had set your Electro server home, in my case it's in Electro server 4_40_6, and you will basically place all of the copies of the extensions that you need to use under the server folder on your Electro server. And then you will find another subfolder there called extensions, and then you copy your extensions there. So let me show you how you can do that. Let's first go and find the gamebook extensions from the content of the class, and I'll just place them. I have placed them in the resources. Okay, the extension files that we will be using in this class are under the resources subfolder. If you click on resources, you go to gamebook programs, click on the gamebook programs, and then you see a folder called extensions. Click on the extensions and then download a copy of gamebook compressed file. So I will save this file onto my local computer, and let me just take this copy and I would just place it in my desktop here. Okay, now I need to extract this. Let's extract this extension or this compressed file, and then copy the gamebook folder and then paste that copy into your Electro server folder for the extensions. So go to your C drive, the area that you deployed your Electro server home, go to the server extensions, and then copy the gamebook extension in your Electro server folder. And then when you copy the Electro server extension there, restart your Electro server. Okay, now my Electro server has been restarted. I can go and associate any server level components that I need to use. To do that, we need to use the administration panel to mark the server level components the first time they are added. This only needs to be done once for each of the server level components. So for this unit, we don't need to do this step, but however we will go and I'll show you how we can use the timestamp plugin that is provided in the extension that I just added to the server, and how we can use that and associate it as a plugin, and then we use this plugin later on in our other examples and other units. So we need to open the administration panel of my Electro server, and to open the administration panel while the Electro server is running, we need to type in https://localhost and the port that my Electro server is installed on, /admin/. Now notice my port is 8082. Your port may be different when you install your Electro server. To find that port, you go on your Electro server installation folder, click on the server, click on the config, and then see what the contents of ES configuration are. In my case, My host is 127.0.0.1. That's my local host, and my port is 8082. So when I do this, then I will be taken to my administration panel, and I will log in. The username is administrator and the password is password. If you haven't changed that, you will be able to log in. When you log into your Electro server, you will see the extensions on the right. And as you see here, we have the Gamebook extension installed in our extension server. Click on the plus sign next to your extension, and then click on the new server level component. In this screen, you will be able to see the Gamebook as the extension in the name field. Now we go and we choose the timestamp plugin from the plugin handle, and then I call the timestamp plugin name to be the timestamp plugin, which is the same as my plugin handle. Now notice that the plugin name and the plugin handle can be different. The ID for these two can be different, but it's usually easier to remember and keep track of the plugin handles and names basically when you match the plugin name and plugin handle in your code and later on. And then we will save our plugin. And so at this stage we are set with our plugin and extension installation. Now next I will show you how you can start writing your program for the data exchange with the dig game. Okay, now let's just walk through the dig game project here and see what is going on with this project. We have a game in which your mouse will be replaced by a trowel, and you have a dirt background and a kind of dusty ground in the background. And when you click anywhere, your trowel kind of shows a dig action, and that's digging a location, and then an animation is going to play for a couple of seconds, and then an object is going to be revealed if there's an object there. If there's no object, then nothing is going to be revealed. If you reveal a spot, when you dig a spot, then that spot cannot be dug again. And if you find an item, the item score will be added to your score, and your score will be updated on the user list. This game is an authoritative server game, and the client basically chooses where they want to dig and send this request into a plugin on the server. The server checks to see if that spot has been dug before. If the spot has been dug, it tells the client that they can't dig there. If the spot hasn't been dug, then the server waits for 2 seconds, plays the animation, and then shows if the item was dug up or if there's nothing there. And you can find two different kinds of objects. There's a dagger, a small coin, a shield, and a little dragon-like key. So to start your program is basically under the client folder, and it's attached to the assignment. So when you download the client's version of your program and then uncompress it, then you would see the client folder, and then you open the diggame.actionscript3 project. And so let's just run a couple of times and see what happens, and we can see the workarounds of our environment. So if I run the program once, the Flash player shows up my environment, the trowel is my mouse, and then I have this background here, and the program automatically logs me as player 570, which is a random number, and it keeps my score. If another player logs into this game, the server would log him in as a different player. Now in this case it's player 365, and then these players can start playing. Okay, so if, I dig in the middle, player 365 digs something and nothing happens because there wasn't an object there. Now player 570 digs in their environment, and they found an object that was worth 2500 scores. And so as you see, the player score in both lists is going to be updated. And so we can keep playing the game. And as you see, this is an authoritative server game, which means that the two players could play at the same time. Okay, so now let's dig this area here. Now player 1 dug this lower left corner area here. If player 2 attempts to dig that corner, actually I probably dug a little bit. So as you see, player 1 played and revealed an object here. If player 2 tries to attempt to dig that area, they will not be able to dig the area because it's already been done. So the server basically keeps track of all that information. Okay, so now we can go and walk through the program, and then we start writing some parts of this code. So if I open the source file, I have 3 action script files. I have the plugin constants, the game flow, and the dig game, and also the main, which is my main object. So in the main function, as you see here, I have a class main, which is my portal of the program. I have a main function, and it creates a game flow object, and it basically calls up my game flow. Let's look at the plugin constants. Under the plugin constants, as you see here, we have a class that associates the constant variables. When the plugin and the client communicate, they basically communicate over an electroserver object. And this electroserver object is basically the primary means of communication between the server through the plugin and the client. We can make this electroserver custom formatted. And we can format this in any way we want. But if we want to have a high volume of message transfers due to, for example, a high number of players playing our game, then we need to make the formatting to be minimized as far as the size of the data exchange. So to do that, we will basically attempt to create a plugin class with associated string values for different entities that we are passing through our client, and therefore we would minimize the byte contents. So for this case, we have certain kinds of actions, certain kinds of parameters, and certain kind of errors. So we associate a constant called action to a string that's basically a small a. If you wanted to send an action, for example, dig here, we would basically use a string that's composed of a small d. If you wanted to have an action basically representing that we are done with digging, we use a string essentially composed of 2 d's, and so on and so forth. So it's basically a simple public class of variables, and we associate names to the contents of the values that are associated to it. So for example, the x and y values for our mouse are essentially associated with the string X and string Y. Okay, so when we create those plugins, then notice here we create an ES object, basically, which is our Electro server object. And then when we want to send its content on the or the values to it, we would essentially call ES_ob.setString, basically set the string for my Electro server object. And then I need to pass two strings to it. So I would go like the string is action and another action called init_me. So what's happening is that I'm using those plugin constants as you see here. So what happens when I call the set string on my Electro server object, basically the string A is going to be sent as the first variable instead of action, and the string I is going to be sent instead of init_me, which is here as the second object. And notice that on the server side we have another set of plugins, essentially, or a set of Electro server object that reads and writes the exact same values at any given step. The reason that we created those plugins is that in order for this project to work, it would basically look like ES_ob.setString quotation A quotation I. But for a user, really this doesn't mean anything. We use the plugin names to basically create a constant meaningful values that we could use. So we know that there's an action, and the action is basically an initialization. But what is going to be passed to the server Electro server object is going to be the string A and the string I. So let me just put this at the end here, basically saying that this is essentially the same thing as using the ES object set string I, A, and I. The same as this. Okay. All right. Now let's go through our project one more time, and then focus on certain areas, and then I'll show you a clean slate for this project, and start writing the parts of code that we needed to essentially write as a part of our authoritative server and thin client logic programming. But first, let's look at the game flow. So first, you have the main that extends the sprite class, and then you have a game flow object associated with it. Your game flow object essentially takes care of the basic contents. You create an Electro server object, and then you create a dig game. You initialize your game flow. In the game flow initialization, you essentially read an XML file to know where your server is and what protocol you will be using. And then you associate event listener, a connection event listener, a login response listener, and a connection event close. So for the connection event listener, essentially, you create a username, which is a random username from 0 to 1000, and then you send that login request to the server. If you're logged in, then you join and you create a dig game class object. You associate the Electro server object to it, and then you initialize it. If not, you show the error. And if any user logs out, you basically close their connection. Now let's look at the dig game class. The dig game class basically, again, uses the Electro server libraries, the elements, the player libraries, and a whole bunch of Flash objects and libraries that deal with your AI, your input and output topics. In your Electro server object, you have an in your dig game object, you have an Electro server object, a room object, a player manager, and a player list user interface. You have an item holder and a trowel. Basically, these you use them for the animation, and also you maintain the list of your username, which is basically the username is a string. That's the person's or each player's username, and also you have variables that sound a digging sound, a found item sound, and a not found item sound. So you create an event listener. Basically, your event is going to be for your dig game. It's going to be a added to stage event, and you call up the added to stage event listener function. In the added to stage event listener function, you basically add two events: a mouse down and a mouse moved event, and then you maintain the programming of mouse down and mouse move event later on within their own event listener functions, mouse down and mouse moved, which are going to be down here. Mouse moved and mouse down. Okay, let's look at our Electro Server event listeners. When we initialize our object, our dig game object, we go through and we basically create a list for the player user interface. That's the white text box on the top right corner of the screen, and we will place it at 490 and 10 pixels on the screen, and we associate some width and height to it. Then we create an item holder and we create a trowel, and then we hide the mouse. Then we create a join room event on join room event as in join room event handler, and then on plugin message event as the plugin message handler. We already talked about join room event. Basically, it joins your users to the room, chat room. So we don't go over that content. The plugin message event is a new event. This event is fired when a new message goes from a plugin to the client. We also create through our initialization system, a username for maintaining the name of each user on the screen, on the user interface, and then we create a player manager. So when the user joins a room, basically, the onJoin room event is going to be fired. So with this event fired, we store the reference to our room in the underscore room variable of our dig game object, and then we send a string to our, or we create an Electro Server object that contains our current player's ES object functionality, which is an action or a pair of action name and action to be sent to our plugin. And so through this, we create an ES object, which is a new instance of an ES object, and we set the string for the action to be the initialization or init_me. And as I said earlier, the ES object using our plugin constant variable that we define is the same as just typing ES object that set string a, I. And then we send our object to the plugin. So the send to plugin function basically takes the ES object that needs to be sent to the plugin. It creates a plugin request, and then it sets the ES object for that plugin request. It sets the room ID and the zone ID, and also it sets the plugin name for that plugin request. In this case, our plugin name is called digging plugin. Then we send the plugin request to the Electro Server, and also we trace that Electro Server object. So if you notice here, the digging plugin is the plugin that we're sending our information to. If you go to your Electro Server extensions, you would see that the extension that I had, that I already added the timestamp plugin as a server level plugin, it also has a digging plugin 2, and so on and so forth. So this digging plugin is the one that's going to be sent. But we're not going to use that digging plugin as an extension or as a server level extension. Okay, so we will send to our digging plugin the action set that we created for Electro Server, the room and the zone IDs, and that would associate it. Okay, so when a player joins a room, basically what's going to happen is that we will create a room request, and the name of the room we call the dig game room, and the zone name dig game zone, and then also we will create a plugin for it. And so we create a plugin and we set the extension name as Gamebook, the extension plugin handle plugin digging plugin, and the extension plugin name digging plugin. And then we add the plugin to the list of our plugins in the create room request, and then we send our create room request to the server. So remember, with the previous example, we didn't use a plugin, so we didn't have to create the plugin and also add it to the list of our plugins in the room. So what we will do is that we will use this plugin name, plugin handle, and plugin extension into our new plugin object, and then we add that into our create room request. Okay, so now we created our room, added a plugin to it, and then notice that when we joined the room, we set a Electro Server object to be sent to the plugin, and we send it to the plugin. And then in the send to plugin, again, I'll reiterate that we set the Electro Server object for it, and the room ID and the zone ID in the plugin name, and then we send the plugin request to the server. So now let's look at what's going on and what happens to basically for us to be able to tell the server where we want to dig. When a mouse click is detected, we will detect the mouse event mouse down event, and we invoke the mouse down event handler. Let's go and find the mouse down event handler. So when the mouse down event handler is initiated, we test to see if the room is not null and if the trowel is basically digging. We create an Electro Server object, and then we create an action name and action pair. Basically, we set the string action and dig here, and then we set an integer for x to be mouse x and an integer for y to be mouse y, and then we send this Electro Server object now to the plugin, which is here. And then we go ahead and animate the digging trowel and we play the sound. So this is what's going to happen when the mouse button is pressed. So we create an Electro Server object, and then we send it to the plugin. And remember, the send to plugin function that takes the Electro Server object, takes the Electro Server object, takes the room, takes the zone ID, and then creates a plugin request, and then sends that plugin request into the server. Now, when the user receives a message from the plugin, the on-plugin message event is going to be called. And I'm going to go and find that event handler. Okay, it's here. So the on-plugin message event is going to be called when the plugin sends the user a message. What we will do is that we need to do the opposite of creating and sending our message to the plugin. To handle the messages coming from the plugin, we use a switch statement. In the switch statement, we just take the action variable that we find on the Electro Server object being sent through the plugin, and then for each case, we pass the Electro Server object to the custom event handler for that action. So we create an Electro Server object, and we get that value from the electroserver object coming from the plugin. And then we create an action string, and that would be the string that comes from your plugin constants. So we get this ES object.getString plugin constant and action. And then we look at the action and see what that action was. If the action was done digging, then we call the done digging event handler. If the action was player list action, then we call the player list handler. If the action was to add a player, then we call the add player handler. If the action was to remove a player, we call the remove player handler. And if the action was just an error, we just handle that error through handle error function. And if the action was anything but any of these actions, then we just basically show the error message as an action not handled. Alright, so now let's go through the list one by one. Let's find the handle done digging event handler. Alright, handle done digging event handler is going to be executed when the done digging action is processed from the electroserver object coming from the plugin on the server on the onPlugin message event handler function. The done digging message is sent from the server to all players in the room when any player has completed a digging action. It broadcasts that player's new score to everyone in a game. If there were if you were the one that were doing the digging, then an item that you find, if you found one, will be added and created onto your screen. So, we first grab some initial information from the electroserver object. So we create a string for name, and then we read the name, and then we create an integer for the score, and we read the score from the electroserver object coming from the plugin. And then we create a player, and the player will be the name of the player, and we update the score of the player with the score that we read from the plugin. Now, if the player is, or if the code that's being processed here was on the player who was performing the digging action, then the travel stops digging function will be called to stop the digging animation for the player, and then an object found boolean will be set, which is either an object found or an object not found. If the object was found, then an item ID will be read from the electroserver object, and an item will be created with its X and Y, and it will be added on the screen. Otherwise, a not found object will be sent. Then the travel position will be updated, and the player list will be refreshed to basically indicate and show that the new score change in the list of all the players. So basically, the idea essentially in this done digging action is that if the done digging action is being sent to other players who haven't done this done digging, we essentially update their scores. If the done digging action happens to be on our own client, then we basically go ahead and update our screen. We need to go and see the refresh player list and see what happens when the player list is refreshed at the end of the done digging. So we create a data provider as we did last time. We go through all the players from the player manager, and then we attach their scores and the names, and then we update our data provider back into the player list. So this is basically the same thing that we did with our chat, but with just maintaining the list of the players and their scores. Alright, and let's go through some of the other actions. So if the player list was in the action coming from the plugin, we handle player list, and in the handle player list, we basically create an array of all the players, and then you go through every single one of the players. We read their electroserver object, we read their names and their scores, and Then if the username and the name were equal, we set that as the player being us. And then we add the players to the player manager, and then we refresh the list. Notice here with my handler, I'm checking the player is me function here, which comes from this little guy up here. All right. The other function that we will be calling is the add player and remove player functions. So if the player coming in or the information coming in from my Electro server is basically the action is an add player, we call up the add player handler, basically create a player, take their names and their scores, and if they're not us, we don't set the p.isme, but if that player was us, we set the p.isme on them, and then we add them to the player manager, and then we refresh the list. For the removing, we just read the name of that player that's being removed, we remove them from the player manager, and then we refresh the player list. When the error comes in, we call the handle error, and basically we create a string, we read that error from the Electro server from the object, and we see if the error was spot already dog. We stop the trowel, we play the sound of nothing being found, we update the trowel position, and we break. And if the error was anything else, we just show that the error was not handled and the type of error, basically. Alright, now that we went through these, we can rerun the game one more time and see how it works. So here, I ran the program. So what happened is that this is me. So when the Electro server object sent the information, or the plugin sent the information back to this client, it says that now a player needs to be added to the list. So my name is added to the list here in my client side, and the player is me is set. So now if I dig here, the player is me is going to be called. If another player joins me or joins the game, as you see here, the second player is added to the list, and basically the plugin communication will be happening between these two players. So when the player clicks mouse down event, fires, mouse down event shows the trowel animation, and also sends the message that I'm digging here to the server. The server handles that message and then sends the communication through the plugin out to both servers. So that when the information comes from the plugin, both clients would read that plugin information and process it. Since this information on the player to the left was the same person, it stopped the digging action and also showed and updated the screen and then updated the score. And also the score on the second screen for the second player is updated, but as you see, nothing is shown on their screen because it wasn't something that they discovered. So when the players exit out, the Electro server object will be sent from the plugin saying that the player such and such exited, and so they will be removed from the list and the list will be refreshed.